All right, thanks. Excited to be here, and thanks for the introduction. So today I'm going to be talking about a descriptive Bayesian account of optimism in belief revision. So it's quite plain that the ability to reason from experiences and evidence to form accurate beliefs about the world is a crucial function of cognition. At the same time, as we're all aware, sometimes the truth can hurt, right? The future can seem bleak. We can fail to live up to our own expectations for ourselves. We can be betrayed by friends or leaders, and so forth. So despite the importance of forming accurate beliefs for our general success in navigating the world, people might also sometimes want to avoid that kind of pain. And this idea has led some researchers to propose that belief revision can be characterized by optimism, a form of motivated reasoning in which bad news is discounted relative to good news when updating beliefs. So just to illustrate, I want to consider kind of the classic seminal study from Sherritt and colleagues, 2011, that was sort of the first of many to promote this idea. So in all these studies, and this and many that followed, participants are asked about different good or bad potential life events that might occur to them. So they might be asked something like, what's the probability that you'll someday suffer a stroke? They make an estimate, and then they're told the true actuarial base rate of that event in the population. So they might be told, in fact, 16% of people will someday suffer a stroke. And then they're asked to report their revised beliefs. So knowing this, what's the probability that you will someday suffer a stroke? And what's been found consistently in this paradigm is that the change in participants' estimates is larger, sort of in absolute magnitude, for good news. So when a base rate is lower for a bad event, like a stroke, or when the base rate's higher than their initial estimate for some sort of good event, like being in a happy marriage or things like that. And so this has been widely taken as evidence for optimism in belief revision. However, there is a pretty serious flaw and problem in this sort of logic of these findings, as identified by Shaw and colleagues in a really interesting paper that basically forms the inspiration for all this. So the actual problem, of course, comes from Bayes' rule, as you probably are guessing. But here's a summary, is basically that people's perceptions of their own risk and the base rate risk are not necessarily exactly the same. People don't necessarily think of themselves as exactly average. So here's an example. We make up some numbers about two reasoners thinking about their risks of skin cancer. So we have Alice and Bob. So Alice thinks that the average risk in the population is 10%, but her own personal risk is only 5%. So she must be diligent with sunblock. She knows that she's protected. Bob, on the other hand, thinks the average risk is only 3%, but he thinks his own personal risk is 10%. So he thinks he's at higher risk. Maybe he's got family history, he's got a very fair complexion, doesn't like sunscreen, whatever it is. So what happens if both of these reasoners are informed that the true base rate is actually 7%? So hopefully you've got the Bayesian intuition that this is good news for Alice. She's been overestimating the average risk, and she's probably been therefore overestimating her own risk. It's bad news for Bob. He's been underestimating the risk. Now he's got to adjust his belief. But the kind of classic paradigm of examining optimism and belief revision from Sherritt and colleagues would have flipped these labels, right? So we would be ignorant of what their estimated average risk is, and we would just compare with their own personal perceptions of their own risk. So we'd reverse things. So I'm going to skip over the algebra to work this out, but Shaw and colleagues show that using the log odds form of Bayes' rule, we can write a formula for the actual rational update for the personal risk estimate that's based on the initial risk estimate. So updated personal risk estimate on the far left, the initial personal risk estimate, plus the difference between the true base rate that people are informed of and the initial base rate that they estimated. So with everything transformed to log odds. And this resulting equation can then be related back to the log odds form of Bayes' rule. So we have our posterior log odds are equal to the initial log odds plus something called the evidence ratio, which is the log of the probability of data given the hypothesis over probability of data given the negation of the hypothesis. And I just want to highlight this because this evidence ratio is basically telling us how much people ought to be updating their beliefs from their prior to their posterior, right? So this is giving us kind of like, this is how you should be updating your beliefs. So thanks to Shaw and colleagues and log odds form of Bayes' rule, we have a rational model of belief revision. So now the goal is to use this rational model and ask whether or not there's an optimism bias. So how does that rational or optimal model compare to actual human behavior? And the way that I've chosen to do this is inspired by this kind of idea fairly recently introduced by Sean Tober and colleagues, this idea of descriptive Bayesianism. So the idea is that we'll take our optimal rational Bayesian account and we'll modify it in various ways to allow it to fit better to human behavior. And in particular, we pay special attention to capturing individual participants' behavior. So the idea is if we can do this, this will give us a test of these motivated reasoning effects that will be kind of valid by the Bayesian zone lights, or at least one Bayesian zone lights. Okay, so going to have a couple of different models of interest. These are all going to be Bayesian multi-level beta regression models. So key things here, multi-level, we're going to be interested in individual people's parameters. And then beta regression, so beta distribution is a probability distribution for probability distributions, so it's very natural for these probabilistic estimates people are going to be giving us in this study. So again, here's this optimal rational model. What we want to do now is create some descriptive models to try to capture human behavior. And so there's two things I'm going to add to this model. So first, I'm going to add a new parameter, alpha sub I. So for each participant, we have some alpha parameter. And this is what we're going to call the conservatism parameter. So conservatism is this common finding that people do not update their beliefs as much as they ought to, as prescribed by Bayes' rule. So they typically update in the correct direction, but just not as much as they should. And so you can see what this is doing, right? So this alpha is multiplying, basically acting like a scaling factor on that final term that was the evidence ratio. It's how much you should be changing your beliefs. So if we have alpha of 1, we just have the rational model again. But if we have some alpha, some value less than 1, right, so 1/2, let's say, then that means we have conservatism. We're updating our beliefs, correct direction, but not as much as we should. And then what we can do is just expand this term out. We can create basically a little linear model inside of our model. And we can add now the optimism parameter. So we'll call that beta. And I'm going to add an indicator variable, G, that indicates whether or not the information is good news or bad news for each person. So if you can imagine this regression, right? So if beta ends up being some positive value, that means we're changing our beliefs more for good news. If it's 0, we're neutral, changing our beliefs just as much for good or bad news. If it's negative, then we're actually pessimistic, changing our beliefs more for bad news than for good news. So this is the setup. So these are the kind of interesting, the models that I'm going to be interested in comparing. So to compare some models, we need some data. So following the sort of spirit of the studies by Sharon colleagues and the sort of exact design of studies by Sean colleagues, I'm going to ask participants about 20 different potential life events, so 10 positive, 10 negative. They're going to respond on a 0 to 100% scale, just freely typing in their answers. First, they'll be asked estimate their own personal risk for these various events. Then they'll estimate the base rate risk. Then they'll be informed of the true actuarial base rate. And then finally, they'll be asked to estimate their own updated personal risk now, knowing that that's the true base rate. So what do we find? So firstly, do we find conservatism as we found in many prior studies? Yes, we do. So what I have here on the y-axis is the alpha parameter from that first descriptive Bayesian model. And this is for the population level estimate. So you can see it's a negative value about 0.6. This is the posterior distribution. So we do have some degree of conservatism. People are, on average, not updating their beliefs as much as they ought to. But we also have substantial heterogeneity across participants. So here I have same thing, the alpha parameter, but now on the x-axis I just have every participant sorted by their alpha estimate. And these are 95% credible intervals. And just of particular interest that I want to highlight is we do have this group of participants who have alpha values that are like roughly consistent with 1, right? So we have a subset of participants who are not indicating a very high degree of conservatism. And in fact, for about 30 of our participants, a rational model with 0 parameters accounts for over 90% of the variance in their belief updating. So that's what I've got here, just a random sample of 9 of those 30, where on the x-axis we have the predicted change in each of their beliefs following the evidence. On the y-axis we have the observed change. You can see we're doing quite well. So we have a sort of subset of participants who are engaging in what looks like accurate and rational belief updating. But on average, we have conservatism, and we have kind of a wide range of values here. Okay, so now the main event. Do we have optimism? Do we have deviations from optimal belief revision that would indicate that the sort of valence of the information is affecting people's beliefs? Do we have evidence of optimism? Perhaps surprisingly, the answer is no. And in fact, we actually see some modest pessimism under this paradigm of estimating these features. So here I have on the y-axis the beta parameter. Recall again, if we were going to see optimism, we'd see some positive value. If we were going to see unbiased belief updating, we'd see essentially 0. We actually see instead is some modest negative estimate. So on average, our participants are actually a little bit pessimistic. But again, we have substantial heterogeneity. So same story, y-axis the beta parameter, x-axis all of our participants now. And again, I'm kind of just doing this thing of highlighting participants whose individual parameter estimates are incredibly negative. So we have a substantial cluster of participants who are reliably pessimists that we can estimate even at the individual level. But we also have a handful of optimists. So we do have about 4 or 5 out of 186 total participants on this graph, about 4 or 5 who are individually reliably optimistic as well. We also have many who seem to be like roughly unbiased, not really pushing either way. So what does this mean, right? So one of the findings that I've just shown you is we have more pessimism than optimism. So what does this say about motivated reasoning? On the one hand, you might see this as kind of, I guess, like sort of a win for these non-rational or motivated accounts of belief revision, right? So we do have that the valence of the information is affecting belief updating. However, it's in sort of the opposite direction as what was typically predicted by these motivational accounts. So the motivation that would drive this is not as obvious as something like, well, it's pleasure seeking or pain avoidance, so you just don't want to accept uncomfortable facts. Could we think of some other motivational account? This is very speculative, but we could potentially. So perhaps pessimism serves some motivational function. It could serve the function of avoiding future disappointments. So I think we often all do this as we guard our expectations, that we try to sort of manage our future emotions by saying, oh, I'm not going to get that award, or they're going to reject that paper, or whatever it is. And that can sometimes be effective. Of course, it comes with the cost of then having those negative feelings and thoughts for however long that persists. So I think more would have to be done to actually make this case that this is really what's going on. But it is plausible. But I think either way, we need to get a little bit more nuanced in our thinking about what are the motivations that could drive this. I also just want to highlight this heterogeneity. I think this is one of the kind of really interesting things that this sort of descriptive Bayesian approach enables us to do, is to explore individual level behavior and to ask how people might differ. So we saw substantial heterogeneity in both conservatism and optimism or pessimism. And in particular, I'm quite curious about this subset of participants who engaged in what seemed like very accurate, essentially rational belief revision, right? So descriptive Bayesianism is kind of one approach we could use to explore this, right? So it'd be worth exploring, what are the characteristics of those more or less rational updaters. So kind of an exciting direction for future work. And then finally, I just want to plug, basically. I kind of think this is I really like this Shah and colleagues paper. I think that this experimental paradigm is a really great potential test bed for examining biases in belief revision. So it gives us an opportunity to apply and compare rational models with sort of clear quantitative predictions, but in a context where we can have much more consequential, more naturalistically kind of valid and interesting topics about which people really will hold motivations or have effective responses to, and so on and so forth, compared to sort of the classic tasks with coin flips and drawing balls from urns and other things like that. So I think this is a really kind of interesting test bed, and I'm hoping to do more myself, but hoping to see other people maybe pick it up as well. All right, so thank you so much, and I'll take any questions.
Yeah, super cool work. Maybe it'll help explain why doom scrolling has become such a national pastime of late. Yeah, so one question I have is, do you have any measure of the magnitude of the valence? So, for example, if I learned that the world is more likely to end than I thought. That's like a, kind of the error there is really bad if I'm sort of underestimating that. But, maybe the probability that I get a bad haircut isn't such a big deal if I underestimate it. So I'm wondering if you've measured at all kind of the valence of any of these items or the magnitude of the valence and if that affects your estimates in any way.
Yeah, that's a great
Thanks.
question. I haven't, but I think that is an important thing to do, and it especially plays into this question of, okay, well, so if these really simple motivations of sort of pleasure seeking or pain avoidance aren't going to cut it, well, then we maybe want to know, kind of have a much more nuanced picture of how people are responding to these things, right? So how bad is it? How bad is it to accept? How bad will it make you feel in the moment to believe that it's going to happen? How bad would you feel if it really did happen? So how effective would it be to kind of try to blunt that future outcome? And then, of course, there's also a question of like whether or not is it something you can do anything about, right? So if it's something that you don't have a lot of agency in, it's maybe not. There's not a ton of utility, right, to forming accurate beliefs if those beliefs are bad and cause emotional pain. But if it is something you could do something about, then you're sort of more in a position where you ought to be accurate, right? So yeah, I think this is a great question and one of the things I want to look at.
Thanks. I wanted to ask about how you're modeling the relationship between base rates and people's individual estimations of their own sort of prior probabilities of getting skin cancer or any of these things. Because you could imagine a person who has the kind of sort of exceptionalist meta belief that sort of says, well, I'm part of this population, but they're influenced by different causal factors. Their risk of skin cancer is influenced by other things. And I'm different because I operate in a different way. And so base rate information isn't really going to be relevant to me. I'm just going to see it as independent. Even though I am going into that average, you might think there's a large population. Most people are affected by different factors than me. And so I don't really need to take base rates into account when I update my own personal beliefs. So I'm just wondering if there's something in your model that could account for that kind of thing, or if you're just assuming that people take information about population level base rates to be broadly informative about their own risk factors for something like skin cancer or any of the other examples you might want to give.
Yeah, great question. I'm going to try to answer it in two ways. So one is I'm going to take the risk of trying to explain a little bit this math, but basically I'll just point out the first part. So this is how we get to that rational model is we start with this first equation on the left here. So someone's initial personal risk estimate, we imagine this is again all in log odds form, is a function of their base rate estimate. So basically the prior belief that they have about whether people will have this event happen to them, plus an evidence ratio that applies to them. So it's their own relative evidence ratio, basically. So what's happening if somebody says the base rate, oh yeah, I think the base rate is 50%, but my risk is only 10%. What they're saying is I have a bunch of evidence about me that says that I'm not exactly like everybody else, and so my risk is much lower than everybody else's. And so this is kind of where we start, and we do a bunch of rearranging and substituting, and that's how we end up with that rational model. So that's, I think, one. I don't want to like leave time for other questions, so I won't get bogged down in actually explaining it or showing it. But that's where that comes from. And then the other thing I think is just I'm just going to use this as an opportunity to mention. We also have these folks on the far left of this plot. So again, this is the. Oh, I'm sorry. Oh yeah. So this is the alpha. This is the conservatism parameter results. So we have a handful of people whose alpha parameters are estimated basically around 0. So basically, they're not updating their beliefs at all. And so I think I'm also kind of interested in what's going on with those people. So maybe there is something to like what you're saying. Another possibility is that they're engaging basically in base rate neglect. So to actually do this update, you have to have kind of an intuitive Bayesian sense, where you have to appreciate that the base rates are informative for your own personal risk, and then you have to like sort of do the thing. And so it could be that there's a subset of people who we give them the base rate and they're like, okay, what's this? This is irrelevant, right? If they don't appreciate that. So there's a handful of people who are sort of qualitatively different, really not changing their beliefs at all. So I want to explore that too.
sensible to ask them to give you an estimate of what they know. That led to their own personal estimate. And that was following up that previous question. And then, as a minor technical point, it would probably be, it wouldn't change your answers, I'm sure, but it might be strengthen your conclusions if you use hierarchical Bayesian analysis and assume there's different groups that are sampled from, and then an individual assigned to that group would be sampled from that subpopulation and so on. So that would probably be just strengthen the conclusions you're reaching anyway.
Okay, yeah, thanks for that. Sorry, it's always hard to think of two things at once. I would just comment on the last point again, just to point out that so these are hierarchical in the sense that we're estimating each of these parameters, we're estimating a population parameter, but I guess the suggestion is that if we really think there's these qualitatively different groups of people, that it could be interesting to put that into the model too. I like that idea, that's interesting.